the weights of the first layer are multiplied by the input of the first layer. Z1 equal to TF matmal function of A1 theta 1. The input of the second layer is the output of the first layer passed through the activation function and the column of bias is added. A2 equal to TF dot concat of NP dot C of NP dot 1's X dot shape of 0 TF dot sigmoid of Z1 comma 1. The input of the second layer is multiplied by the weights. Z3 equal to TF dot matmal A2 comma theta 2. The output is passed through the activation function obtain the final probability H3 equal to TF dot sigmoid of Z3. Cost function equal to TF dot reduce sum of y into TF log H3 plus y minus y into TF dot log of 1 minus H3 comma x1. Built-in TensorFlow optimizer that conducts gradient descent using specified learning rate to obtain theta values. Built-in TensorFlow optimizer that conducts gradient descent using specified learning rate to obtain the theta values. Optimizer equal to TF train gradient descent optimizer learning underscore rate equal to 1 minus r minimize cost function. Setting required x and y values set to perform XOR operation. X equal to 0, 0, 0, 1, 1, 0, 1, 1 values, x values, y values 0, 1, 1, 1 output 0 into 0 XOR function x 0, 0, 1, 1, 1, 0, 1, 1, 1, 0, same value 0, same value, same 1, 0, different value 1, different value 1, 0, 1. This is XOR. Initializing all variables, creating session and running a TensorFlow session. Initialize TF dot global variables initializer. Session equal to TF session. Session equal to run of initialize. Running gradient descent for each iteration and printing the hypothesis obtained using obtained theta values. This is obtained, printing the obtained using this. For I in range 1 lakh. Session run optimizer feed tick of x small x capital X colon and small y capital Y. Setting placeholder values using feed dict 100 equal to w equal to 10. Print echo comma I print output hypothesis session run h3 predict f small x colon to x small and comma small y to capital Y. The above line of code generations and output as shown the screen below. E in the E colon TensorFlow projects activities TensorFlow TensorFlow project Python using XOR gate. This is the core platform CPU feature got CC140. Your CPU supports instructions that this TensorFlow BIOS was not compiled to use AVX2 like you can evoke 0, evoke 100 for evoke 0 hypothesis this is value 1, 2, 3, 4 for 100 this is 0.29 here 0.63 up to 414 0.414 for epoch 200 0.023 for epoch 300 0.112 for 400 0.0073 reducing exam reducing 500 hypothesis 0.0054. So in epoch 600 hypothesis 0.0043 output. So next chapter gradient descent optimization in the tensor. Gradient descent optimization is considered to be an important concept in data science. Important in data science. Consider the steps shown below to understand the implementation of gradient descent optimization. Gradient descent optimization. Step 1. Include necessary modules and declaration of x and y variables through which we are going to define gradient descent. Import TensorFlow as TF x equal to TF variables 2 comma name equal to x t type TF float 32 log x TF log x squared TF squared log x correspondingly same optimizer TF train gradient descent optimizer 0.5 train optimizer minimize log x squared step 2 initialize the necessary variables and call the optimizers for defining and calling it with the respective function. Initialize TF initialize all variables. The definition optimization here starting definition optimize with the TF session as session run initialize control print starting at the x session run x log x power 2 session run log x squared for step in range 10 session run train print step x session run x log x power 2 session run of log x squared. Optimize. The above line code generates the output as shown screen below. Here also TensorFlow in eDrive, TensorFlow project Python ged underscore symbol dot py. This is the file. Their warning also came. Initialize all variables from TensorFlow. Python of variables it is represented and will be removed after like this coming. Instruction for updating global variables initialized instead. Same like this will come in the your CPU supports instruction that is it TensorFlow binary was not compelled to use wavext like this coming. So sorry. So starting x equal to 2.9 log x power 2 value 0.48. Second step 0 x 1.6 log x power 2 0.252. Step 1x 1.34 log x 0.08. Then step 2 log x power 2 0.014. Then step 2 finish. Step 3 0.004. Then step 4 4.14. Then 5 3.5. Step 6 1.0 log x power 2 0. Log step 7 1 value into log x power 2 0. Step 8 1.0 log x power 2 0 same. Step 9 same here all are same 0. Okay, yeah, we can see that the necessary epochs and iterations are calculated and shown in the output. TensorFlow forming graphics. The partial differential equation is a that is PD differential equation which involves partial derivatives with unknown function of several independent variables. With reference to partial differential equations, we will focus on creating new graphs. Let us assume there is bond with dimension 500 into 500 square, n equal to 500. Now we will compute partial differential equation and form respective graph using consider the steps given below for computing graph. Step 1 import the libraries for simulation, import TensorFlow TF, import NB as NP, import matplotlib library dot pyplot as PLT. Step 2 include the functions for transformation of a 2D two-dimensional array into a convolution kernel and simplified 2D two-dimension convolution operation. Definition: make kernel of A equal to np dot as array of A equal to A dot reshape of list of A dot shape plus 1 comma 1. Return TF constant of A data type equal to 1. Definition simple of conversion of x comma k. A simplified 2D convolution operation x is equal to TF expand dimensions TF expand dimensions x comma 0 comma minus 1. Y equal to depthwise convolution 2 dimension x of x k of 1 comma 1 matrix padding same. Return y of 0 comma 0 0. Definition Laplace of x. Compute the 2D Laplacian of an array. Laplace k make kernel 0.511